Hello students, today we will discuss IB Physics SL, Paper 2, May 2021, Time Zone 2. In this paper you should use calculator. My name is Nariman Melim, I am located in Baku, and here you can see my mobile and email. To prepare for exam, main huge textbook is from Oxford, 2014, short textbook from Tsokos, and a very short study guide from Tinker for deep understanding and revision. When you are doing past papers already, you should have physics data booklet, first assessment 2016 copy, and I recommend you to have 5B physics guide also. Let's start. Okay, so this exam took place on 3rd of May 2021. It is for 1 hour 15 minutes. Let's start. Question 1. If a football player kicks a stationary ball of mass 0.45 kg towards the wall, the initial speed of the ball after kick is 19 meters per second. And the ball does not rotate. Air resistance is negligible and there is no wind. The player's foot is contact with the ball for 55 milliseconds. Calculate the average force that acts on the ball due to the football player. So mass is given, velocity is given, time of action is given, subtopic 2.4 from booklet. Give us formula for momentum and for force. Force equals change in momentum divided by time. So change of momentum is mv minus 0 because at the beginning it was stationary. So we rewrite formula for force, put the values, and we get to two significant figures, 160 Newton. The ball leaves the ground at an angle of 22 degrees. Horizontal distance from the initial position of the edge of the ball to the wall is 11. Calculate the time taken for the ball to reach the wall. So distance is 11 meters. Horizontal component is cosine of initial component. So it is expression 19 times cosine 22. Not in booklet, speed equals distance over time, time equals distance over speed, so we put values, calculate, and we get to two significant figures, 0.62 seconds. The top of the wall is 2.4 meters above the ground. Deduce whether the ball will hit the wall. Let's choose upward direction positive, then acceleration will be negative, initial velocity vertical will be 19 sine 22 plus, time is the time after which the ball appears at the position of the wall. From section 2.1 we have this vertical displacement formula. So we put values of acceleration, time, initial velocity, which is positive. We take into account the signs and we get 2.5 meters. Ball does not hit the wall because wall is 2.4 meters, so it goes above the wall. In practice, air resistance affects the ball. Outline the effect that air resistance has on vertical acceleration of the ball. Take the direction of the acceleration due to gravity to be positive. So they suggest to have downward direction positive. In any case, acceleration equal resistance force over mass, mg minus air resistance divided by mass. So when ball is moving upwards, speed decreases, air resistance decreases, acceleration increases. When it goes down, upward, so we have air resistance, mg is down, air resistance is also down, so it is negative. Actually, here we have plus minus. Yeah, plus minus. We have here plus or minus. When it is going up, we have plus. When it is going down, it is minus. As a result, resultant force first will be greater, and then will okay, and it will be decreasing. Right, so mark scheme answers are given. So here plus minus, better choice, because it goes up. When it goes up, mg is down, air resistance is down because it is against velocity. When it's going down, mg is down, but air resistance is up because it is against velocity, so g will be less. And during this going up and down, it will be decreasing. Right, okay, the player kicks the ball again. It rolls along the ground without sliding with horizontal velocity of 1.4 meters. The radius of ball. Calculate the angular speed of the ball. State an appropriate SI unit for the... Yes, tangential velocity is the same as horizontal velocity, 140. Radius is given. From subtopic 6.1 we get formula linking tangential speed with angular speed. We write this formula for angular speed. We put values and we get certain radians per second to two significant figures. Graph. Question 2. Graph shows the variation with temperature of pressure of a fixed mass of helium gas trapped in container with a fixed volume. Temperature is in Kelvin. A. Deduce whether the helium behaves as an ideal gas over the temperature range from 250 to 500. So first of all, we see that it is straight line. The question is whether it goes through origin or not. So not to check whether it goes into, because origin is not given, we can check proportionality by ratio. So let's take ratio of pressure and temperature at temperature 250 and another at temperature 500 Kelvin. So if we calculate ratio, we see that it is 400 and it is constant. So pressure and temperature are proportional and gas behaves as an ideal gas. Helium has a molar mass so much. Calculate the mass of gas in the container. So molar mass is given. We change it into kilogram. Volume is given. Pressure we change into Pascal. Temperature is given. For example, we take temperature 250 Kelvin and pressure then will be 1,000 according 100,000 according to the graph. Some topic 3.2 give us formula gas equation in which we have number of moles, pressure, volume, and absolute temperature. So we rewrite this formula for so number of moles will be mass by molar mass. We put this expression into gas equation, then rewrite the formula for mass of a particle, and we get 0.19 gram, the mass m of the gas. C. A second container of the same volume as the original container contains twice as many helium atoms. The graph of variation of P with T is determined for the gas in the second container. Predict how the graph for the second container will differ from the graph for the first container. Again, subtopic 3.2 give us gas equation. We write this formula for pressure, and we see that pressure is proportional to Kelvin temperature. And when number of moles increase 2 times, gradient of graph also should increase 2 times. So from Mach scheme they say that pressure will double, graph will be steeper, but graph still goes through the origin, which is nonsense because we don't see origin. Right. Question 3. A vertical wall carries a uniform positive charge on its surface. This produces a uniform horizontal electrical field perpendicular to the wall. A small positively charged ball is suspended in equilibrium form from the vertical way as by a thread of negligible mass. The charge per unit area of the surface is sigma. It can be shown that the electric field strength due to the charge on the wall is given by the equation sigma over 2 epsilon 0. Demonstrates that the units of the quantities in this equation are consistent. So for sigma we get charge, it is density of charge. It is charge per unit area, so charge per unit area is coulomb per meter squared. Then we take from booklet the unit for epsilon 0 and value. Subtopic 5.1 tells us that field strength is force over charge, which means that left side of the equation field strength is Newton per coulomb minus 1. Right side has units coulomb per meter squared divided by coulomb squared Newton minus 1 meter minus 1. After simplification, we again get Newton per coulomb minus 1. So units are in the equation consistent. Units in the equations are consistent. The thread makes an angle of 30 degrees with the vertical wall. The ball has a mass of so much. Determines the horizontal force that acts on the ball. So this is a picture. So thread is at an angle theta. The force is horizontal, weight is vertical, and tension is along the thread. So we have actually a triangle of forces, and tangent equals horizontal force by weight. So tangent equals horizontal force by weight. So horizontal force equals mg tangent. G is 981. Mass is given. So we use calculator and we get 0.14 Newton. Two significant figures. Double I. The charge of the ball is so much, determines sigma. So we have charge, horizontal force, epsilon 0. So we rewrite formula for sigma, substitute expression for sigma, rewrite formula for sigma, put values, and we get 2.1 10 minus 6 Newton per coulomb. The center of the ball, still carrying the charge, is now placed from a point charge Q. The charge on the ball acts on a point charge at the center of the ball. P is the point on the line joining the charges where the electric field strength is 0. The distance PQ is 0.22. Calculate the charge Q. State your answer to approximate number of significant figures. The force will be, so the force is given by this expression. Field strength is given by this expression. So left charge field strength is given by this expression. Right charge create field strength, and because they are equal, so field strengths are equal and opposite. This expression are equal and opposite. We simplify, rewrite formula, and we get expression for the right charge, and we give answer to two significant figures. Question 4a. During electron capture, an atomic electron is captured by a proton in the nucleus. The stable nucleus thallium can be formed when an unstable lead nuclide captures an electron. Write down the equation to represent this decay. So because electron is captured, so electron charge -1, nuclear number 0. So we have -1, 0. As a result, neutrino is 0 and 0. As a result, if we go backward, atomic mass of plumbum will be 205 to have a balance of top numbers, and bottom number will be 82 to balance bottom numbers. The neutron number n and the proton number are not equal to the nucleate tedium. Explain with reference for the forces acting with the nucleus the reason for this. So what we see for this nuclide, number of protons is 81, number of neutrons is much greater. So why we have so many neutrons? Because neutron will give us nucleon attraction, strong force, is short range. Electrostatic force is long range. More electrons than protons need to hold nucleus together. So two ideas from this list will help you. Part C. Thallium 2005 can be also formed from successive alpha and beta minus decays of unstable nuclides. The decays follow the sequence alpha, beta minus, alpha. The diagram shows the position of thallium on a chart against the proton number. Draw 4 arrows to show the sequence of changes to N and Z that occur as the thallium is formed from unstable, right? So the last one is alpha. It means that thallium was formed when two protons and 2 neutrons were lost. Attention, here you see the scale is by 2. So thallium last stage was this arrow, 2 electrons, 2 protons. Beta minus means that number of neutrons decrease by 1 and number of protons increase by 1. It is 2 stages. And again, alpha is this arrow. So we have 1, 2, 3, 4 stages, and we mark them. Question 5. Describe 2 ways in which standing waves differ from traveling waves. So mark scheme answers are given here. You can read and choose 2 of them. A vertical tube open at both ends is completely immersed into a container of water. A loudspeaker above the container connected to a signal generator emits sound. As the tube is raised, the loudness of the sound further reaches a maximum because a standing wave has formed in the tube. Outline how a standing wave forms in the tube. Sound waves travel down tube and is reflected. Incident and reflected waves combine and interfere. The tube is raised until the loudness of the sound reaches a maximum for a second time. Draw on the following diagram the position of the notes in the tube when the second maximum is heard. So first the tube was at position, the top of tube was at position 1, where we observed first maximum. And then next is position 2, when we observe second maximum. So node is at the surface, antinode is always at open end. And these are requirements from mark scheme. Node shown at water surface and 2/3 away from the tube, up the tube. 2/3, so you divide antinode, node, antinode, node, divide by 3 parts and 2 parts above. Between the first and second position of maximum loudness, the tube is raised through 0.37 meters. The speed of sound in the ear so much determines the frequency of the sound. So as we can see, the loudspeaker was moved antinode distance, which is lambda over 2. So lambda over 2 equals this distance. So lambda equals 2 times this distance. Subtopic for 2 give us formula for speed. We rewrite this formula for frequency and we get 430 Hertz. Two significant figures. Question 6. A photovoltaic cell is supplying energy to an external circuit. The photovoltaic cell can be modeled as a practical electrical cell with internal resistance. Intensity of solar radiation incident on the photovoltaic cell at a particular time as the maximum for the place where it positions. The following data are available: operating current, output potential difference, output EMF, area of panel 350 by 450. Explain why the output potential difference to the external circuit and the output EMF of the photovoltaic cell are different. Subtopic 5.3 give us formula EMF equals current times external resistance and internal resistance. Output is actually external potential difference, potential difference. And it is EMF minus potential difference that falls on the internal resistance. So some potential difference falls on internal resistance called lost volts. B. Calculate the internal resistance of the photovoltaic cell for the maximum intensity condition using the model for the cell. So EMF is given, output voltage is given. So to find resistance, we rewrite this formula for resistance. So EMF minus lost volts divided by current give us two significant figures, 7.2 ohm. The maximum intensity of sunlight incident on a photovoltaic cell at the place of the Earth's surface is so much. A measure of efficiency, energy available every second, energy arriving. It determines the efficiency for this photovoltaic cell where the intensity is at maximum. So energy available is current times potential difference, external potential difference. Area we turn into meters squared. So area arriving will be Earth's maximum intensity by area. So we get so much. We divide arriving by produced and we get 0.12 or 12%. State two reasons why future energy demands will be increasingly reliant on sources such as photovoltaic cells. So I took answers from mock scheme. So you can pause, read these answers. So paper is over. Thank you for your attention.